Any questions on the homework from yesterday? Hopefully you found the homework from yesterday pretty easy. Now, what we're looking at today is the other type of exponential function. Exponential function with e. E is kind of our natural base, and it will come up with logarithms. It is also one of the special types of numbers such as pi and I. It is considered to be a type of irrational number because it does not actually have a significant decimal, where you can't rewrite it as a fraction. Natural base e, if we wanted to kind of calculate it out, comes in the form of 1 plus 1 over x to the x is the actual function. If we want to kind of get somewhat close to the value of e. So a lot of times we treat e as a variable. Now e approaches 2.718288182846, and it just continues on and on and on. So it can be considered an irrational number. And we can kind of treat it as a variable as well. So we can do stuff like e to the third times e to the sixth. Well, e to the third times e to the sixth, anytime we have the same base, we can add the exponents. So what would this be? E to the ninth. And we'll leave it as that because it is an irrational number, but we're just going to leave it as e to the ninth. We can do the same thing with 16e to the fifth divided by 4e to the fourth. So we can do 16 divided by 4, which is, well, and whenever we have like bases, we subtract the exponent. So 5 minus 4 is 1. So 4e to the first, or we can just say 4e. That's it. 3e to the negative 4x squared. Well, our powers of exponents say we can square both. So we'd have 3 squared e to the negative 4x times 2, because powers of powers multiply. Well, what is 3 squared? Our negative 4x times 2 would be negative 8x. And well, to make the exponent positive, we have to move it from the numerator to the denominator. And that'd be it. Questions on this here? Nothing really new. We're just using our properties of exponents to just rewrite these. Let's do these 3 and then we can move on. E to the 7 times e to the fourth is e to the 11. Because when we multiply, we add the exponents. And when we divide, we do subtract. So e to the 8th over e to the 5th, 8 minus 5 is indeed 3. And does 24 divide by 8 evenly? It would be. So this here is 3e to the third. And lastly, we have 10e to the negative 3x cubed. So we're going to cube both the 10 and e. Now 10 is just going to be 10 to the third. Our e to the negative 3x, well, this is going to be multiplied by 3. Powers of powers multiply. Now 10 cubed is what? And then we'd have e to the negative 9x. But to get that exponent positive, we have to move it from the numerator to the denominator. We get 1,000 over e to the negative, or e to the 9x. Questions on this here? Do we feel comfortable with these here? Now we also have considered exponential growth and exponential decay. Now for these here, these functions come in the form of y equals a, oh, stop scrolling, a times e to the rx. Now when we talked about exponential growth and exponential decay yesterday, we said it's growth whenever b was greater than 1. And it's exponential decay if the value b was between 0 and 1. But here in both cases, our value of b is, well, e. E we already know is 2-point decimal going on. It is greater than 1. So how can we distinguish between the two? Well, the main way we distinguish is the exponent. If the exponent is positive, it's going to be exponential growth. And if the exponent is negative, it's going to be exponential decay. And in both cases here, we're mainly going to consider a being greater than 0. We're going to really focus on the positive case for either one of these here. And the reason that this works this way is because if we look at, say, y equals e to the positive x, well, that's just e to the x. And as we've said, e is greater than 1, so it's growth. That makes sense. Now, y equals e to the negative x, we're saying is exponential decay, yes? Well, if I want to make that exponent positive, we move it from the numerator to the denominator. So we're saying this is 1 over e to the x, yes? Now, according to our exponential properties, we could actually say that this is y equals 1 over e to the x. And this seems like a little bit of a weird step because, well, the numerator, 1, did not have x attached to it. But 1 to any power is still, well, 1. I haven't actually changed anything. But now, 1 over e, is that less than 1 but greater than 0? Yeah, so it still follows our exponential properties. But instead of kind of going through that whole walkthrough for this here, they're just saying if our value of our exponential growth, if the exponent's positive, it's growth. If the exponent's negative, it is decay. We wrote in A, y equals 3 e to the x would be growth because the exponent is positive. How about e to the negative 0.5x? Decay. And it's not so much that the exponent is a decimal, it's more that it is negative. Now, close that. Now we can look at this. So y equals, the first one was 3 second e to the x. And the next one we had was just e to the negative 0.5 x. Second e to the negative 0.5 x. Graph. So the blue one, indeed, looks like our exponential growth. And the red one does show the exponential decay. And it's more based off the fact that it's negative, not so much that they have a decimal. So if I came down here and removed the decimal and just said negative 5x, indeed, it still shows an exponential decay function because we're coming down as we go from left to right. Questions on this here? So number 4 would be growth because the exponent is positive. How about number 5? Decay because the exponent is negative. How about 6? Growth because it is positive. That's it. Now the last thing we're going to look at is continuously compounded interest. The way I've always remembered this one, continuously compounded interest, is PERT. PERT, P-E-R-T. That's what, if I just straight read it as a word, it is PERT, P-E to the R-T. That's kind of how I've kept this one straight, or at least been able to remember it easily. Where P is the principal, R is our rate, and T is our time. And normally time is expressed in exactly years. And we could go through looking at this and calculating interest, but we're not going to worry too much with this here, because that's all we're going to do. I'm not going to be asking about doing those. So we're on page 311. 4 through 10 even, 15 through